We're going to look at dealing with fractional expressions. We're going to be looking at simplifying fractions that have algebra or variables in them. We're going to look at multiplying and dividing fractions, adding, subtracting fractions, and dealing with roots that are in fractions. So the first thing you want to do is typically go ahead and factor, because you can only cross out things that are multiplied by the top and multiplied by the bottom, meaning common factors. You cannot cross out common terms. Looking at this first problem here, the top line ends in a 5, the bottom line ends in a 5. You cannot cross out anything between the 5 and the 10 because it's not 5 times the top and 5 times the bottom. So you want to go ahead and factor the top and the bottom, and we're not going to spend a lot of time factoring because that's not the focus of today's lesson. So you do your AC factoring on the top, you do your AC factoring on the bottom. Now you can see that you have an x plus 5 times the top and an x plus 5 times the bottom, so that's a special form of 1. So you're only left with the other parts. The next problem here, you have a fraction divided by a fraction. Typically, we don't like to divide. We change that into multiplication. We multiply by the reciprocal. So we've got to take that second fraction and flip it upside down. Then we'd want to go ahead and factor. So we'll factor the top. The first one is differences of squares. Factor the first denominator. We'll do our AC factoring there. On the top right one here, we'd want to do our greatest common factor and then see if we can do anything else after that, which we can't. It's only a greatest common factor. On the lower right one, the last denominator, you want to do your greatest common factor, and then it would be sum of cubes, and you'd factor that. Now, at this point, you'd want to see, is there anything the same top and bottom? Yeah, I have an 3x plus 2 top and bottom. I have an 3x minus 2 top and bottom. I have this top and bottom. And I have one other thing. I have an x times the bottom here and an x squared times the top here. So I can take an x out of the top and the bottom. Then all I have to do is write what I have left. The only thing I have left on top is an x, and the bottom I just have that parenthesis of an x minus 1. You're not able to cross the x's out here because it's not x times the top and x times the whole bottom. So now we're going to look at subtracting fractions. To add or subtract fractions, you have to have a common denominator. Well, we have that here, so we could write it as one big fraction. Now, once you get it as one big fraction, you want to factor the top and the bottom, because if you ended up working a problem out as 15 over 25, you wouldn't want to leave it like that. You'd factor the top, factor the bottom, and then you cross out your common factors, which is a special form of 1. So we're going to do the same thing here. We'll factor the top and factor the bottom. Now, yes, you could pull out just a positive 5 on top, but there's a reason I pulled out a negative 5. That's because if I pull out a negative 5, I end up with this negative 3 plus x, which is really this here. That ends up being the same as this and this. So then I'm just left with that negative 5 on top and then x plus 3 on the bottom. If I had not pulled out that negative 5 and pulled out a positive 5, it would not match perfectly top and bottom. Next problem here on the right, we have a negative exponent. Remember, a negative exponent means 1 over that, still with our minus x, which then is a fraction minus a fraction. So we can do bring down our first one, bring down our second one, then we have to do a common denominator. Our common denominator would be x to the fourth, so we got to multiply the second fraction by x to the fourth in the bottom, but if we multiply the bottom by that, we got to multiply the top by that. So now we get the same denominator. We could write it as one big fraction. We take our first numerator, minus, and take our x times our x to the fourth, and we get x to the fifth. So this relates to one of the problems we did in an earlier section. We're dividing by one term. Whenever you're dividing by one term, you can take each term on top, divided by that one term and write it as separate fractions. Now that it's as separate fractions, you could rewrite your square root of x as a x to the 1/2. Now you can look at that first fraction and say, oh, which one has more x's, the top or the bottom? And if it's 2 on top and 1/2 on the bottom, you know there's 1 1/2 more on the top. You look at the second one, which one has more x's? Well, you know there's a 4 there. Which one has more x's? It's an x to the first on top, x to the 1/2 on the bottom. There'd be an x to the 1/2. There's no x's on the top here, but we could bring this x from the bottom up to the top as a negative exponent. Now, as a side note here to review how to be able to add and subtract fractions, suppose you had 7 over 24 plus 5 over 18. The first thing you'd want to do is do the prime factorization of each denominator. Prime factorization of 24 is a 2 cubed times a 3. Prime factorization of your 18 is a 2 times a 3 squared. Then you want to write your least, you want to write your least common denominator. You want to write all the different things that show up, which are just 2's and 3's up here. Write down 2 and 3. Then, if you have a choice on exponents, which we do, either a cubed or a 1, you always take the higher exponent. Or when you're looking at the 3's, you have a 1 or a 2, you take the higher exponent. That's how you come up with that LCD. So now that's our least common denominator. That's what we want all the bottoms to look like. This first fraction doesn't have that. It needs an extra 3 in the bottom. But if I multiply the bottom by 3, I got to multiply the top by 3. Because 3 over 3 is a special for a 1, and multiplying by 1 does not change the value, only the appearance. Here we need a 2 squared top and bottom. So now that we get 21 here, we get 4 times 5 or 20 here. Same denominator, we could write it as one fraction. We could take 21 plus 20, which is our 41, over our denominator. Now, in this case, 41 is prime. If 41 wasn't prime, I'd try to factor the top to see if I had any factors the same top and bottom. With this particular problem being all normal numbers, I would go ahead and at the end take my 2 cubed times 3 squared and multiply it out to 72. But that's the process of multiplying or adding and subtracting fractions. So the first thing you want to do is factor each denominator. Now, notice this first one here is really a 3 or x plus 3 all squared because both parentheses are the same. So you write down all the different things that show up, which are an x plus 3 and an x minus 3. Nothing else shows up down here. But then if you have a choice in exponents, which is 1, or this, which is 2, because it really shows up twice, you take the higher exponent. That's your least common denominator. So then you got to ask yourself, what do I have to multiply that first fraction top and bottom by to get that least common denominator? Well, that first fraction's missing an x minus 3. Multiply the top and the bottom both by x minus 3. The second fraction's missing an x plus 3 squared. So we already have an x plus 3, so it needs another x plus 3 top and bottom, special form of 1. And the last fraction is needing an x plus 3 all squared top and bottom. So this first fraction we could write together and we could work out the top. We could FOIL out the top. FOIL out the top, that 2x plus 6 times the x minus 3. FOIL that, we get this. The second fraction here, we get this here. We could multiply together the top. We get this, distributing through that 5x. And then the last fraction, we could go ahead and take our x plus 3 times another x plus 3, FOIL that out, then distribute through our 7, and we would get this. Now, at this point, all we want to do is go ahead and look for like terms on top. You'll notice we have some squareds. We have 2 of the x squareds plus 5 of the x squareds plus 7 of the x squareds, which would be a total of 14 of those squareds. Then we have some normal x's. Now, notice negative 6x and positive 6x, they drop. They cancel each other out, giving you 0. You have 15 of the x's plus 42 of the x's is 57 of the x's. And then you have your negative 18 and your 63, which is 45. Still over that common denominator. Sometimes at this point you are done, but once again, you want to see if it's simplified. So you'd want to check, does the top factor? Well, there's no greatest common factor, but you could do your AC factoring on the top. If you did AC factoring, you would eventually get to this. Then you'll notice that on the top, you have an x plus 3 to the first, and you have an x plus 3 squared on the bottom, so it leaves you with 1 extra x plus 3 on the bottom, and so that crosses out, leaving you only with this. So before we do this problem on the left, suppose we consider this problem here on the right. We have a negative exponent here, a negative exponent here, a negative exponent here. Can we just move this 3 to the negative 2 down to the bottom, this 4 to the negative 1 down to the bottom, this 5 to the negative 1 up to the top? Well, the answer is no, because if you work out the right-hand side, you get 9 minus 4 on the bottom, which is 5. 5 over 5, you know, is 1. If you follow the order of operations here on the left, 3 to the negative 2 is 1 over 3 squared, or 1/9. This would be a 1/4. Then you have to do a common denominator between 1/9 and 1/4, which is 1/36. So you multiply top and bottom by 4, so you get 4 over 36 minus 9 over 36, still over 1/5. You multiply or add the top, add and subtract the top, you get negative 5 over 36. So dividing by a fraction, you multiply by the reciprocal, you get a negative 25 over 36. Obviously not 1, so it doesn't work. So you can't move the negative exponents to the other part of the fraction when there's a plus or a minus here. If it was all multiplication and division, well, yes, you could. So we got to work this one here out very similarly. This is a negative exponent, so it means 1 over y squared. Negative exponent, so 1 over x squared. Our big fraction bar here, our big fraction bar here. 1 over y squared, negative exponent, 1 over an x squared. So now all we have to do is do a common denominator here on the top, which would be x squared, y squared. So the first fraction needs an x squared top and bottom. The second fraction, to get our common denominator, would need a y squared top and bottom. Similarly, on the bottom here, our common denominator is x squared, y squared. So the first fraction needs an x squared top and bottom, and a y squared top and bottom for the second one. Remember, each one of these green fractions is really a special form of 1. So now that the top has the same denominator, we could go ahead and write the top as one big fraction. Notice it's a 1 times an x squared minus a 1 times a y squared over our common denominator. On the bottom, it's a 1 times an x squared plus a 1 times a y squared over our common denominator. So now we have a fraction divided by a fraction. So I'll take my first fraction on top, put it down here. Instead of dividing by a fraction, you multiply by the reciprocal. Now here, notice you have an x squared y squared multiplied by the top and an x squared y squared multiplied by the bottom. We can write what's left. Now, we cannot cross out the x squareds because it's not x squared times the top and x squared times the bottom. Same idea with the y squareds. Notice that the top is differences of squares, so you could factor that, but the bottom doesn't factor, so we're not going to do anything here.